The ice cream truck just won't leave. Hey guys, I'm Leslie. I am a chemistry graduate student. Usually I don't spend all my time doing chemistry, but for a couple weeks there, I did. Because I was trying to figure out what was in this magic remover for gel nail polish. Yes, it's like very important that I figured this out. It really, it wasn't that important. The reason I'm doing this is because I watched a Simply Nailogical video. Like, that's where all great science experiments start, right? Like, watching a YouTube video. But Christine was testing this stuff, and it does this weird, like, it looks like a chemical reaction when it takes off the gel nail polish. And I was like, ooh, chemistry. Then she said it smelled like paint stripper. And I was like, ooh, what's in paint stripper? And then it said methylene chloride. And I said, I used that once. And my professor said, put on 2 pairs of gloves. And it's a big leap to say, oh, it smells like paint stripper, must be paint stripper. But, you know, there are similarities, including like how it looks when it's taking off the paint / nail polish. So then I got actually more interested, and then I was like, well, a girl needs a hobby. So I ordered it, bugged my professors, and got to work. So first thing I did was ask the companies for the ingredients, but I asked for it in the form of a safety data sheet. This is like a more robust kind of thing than a ingredients list typically, and it has some more safety information for if like there's any kind of other accident with it. I don't know, like if you ingest it, it's like got a bunch of warnings and stuff. But they usually have to provide that to you. I got 2 out of the 3 that I requested. The one that I didn't get was actually the product that I received. So when I'm making all these comparisons, just keep that in mind, that like what I actually have might not even be what I'm comparing it to in the ingredients. So yeah, I got the ingredients list. It was kind of vague, but I did some little sleuthing and I figured out roughly what I think each thing is. They had roughly the same ingredients but different proportions, and so I made 2 dupes and just tested out which one worked better on a little blob of gel nail polish. One thing I did not add is cellulose, which I believe is used as a thickening agent, but I can't be sure. Like, I don't know the reason behind all of these ingredients, honestly. But I didn't add that to mine. So the one that was better moved on into the next round of testing. I took my gel nail polish remover and ran it through a bunch of tests. First being that I had to dissolve it, because most of the tests I wanted to run it through, it couldn't be like a goop, which is like what it is. It's pretty goopy. Methanol was the solvent that worked best, but of everything I used, there was still this like shell of like something left behind, and based off of the ingredients, I'm pretty confident that that was cellulose. Just because cellulose is known to not dissolve in like anything. So then I did what's called a fractional distillation. You might be familiar with distillations because distilleries use this technique to separate components that are in alcohol to get a more pure form of the alcohol. And that's basically what I did. This works by separating things based on boiling point. So if you have liquids with a different boiling point, typically you can separate them. So I started there, and interestingly, I got a fraction at about 40 degrees Celsius, which is the boiling point of methylene chloride. And then I didn't actually get any good fractions out after that because I had so much methanol dissolved that by the time all of that was dissolved, there's just like a little bit left of like liquid, and there wasn't even enough to like get up and through the column. Gas chromatography I know would have been better, but I wasn't about to deal with that. honestly. That's kind of a pain. Then I did what's called infrared absorption spectroscopy. That's really interesting because you can tell what kinds of bonds are in a sample based on how much energy it takes to absorb. So there's different energies needed to stretch different bonds based on like what's on either end, carbon oxygen, carbon carbon, that sort of thing, and how strong the bond is, single, double, triple bond. So you can actually get pretty good information from an IR. So I did that on the fraction that boiled at 40 degrees. I did it on my pure sample, like straight out of the bottle. I did it on the dupe that I made, and I also did it on methylene chloride, just because I was interested, like, oh, where does that show up? And so then I did some comparison, and that was very interesting. As you can tell, there's pretty good agreement between the methylene chloride and our like sample straight out of the bottle, which is like, it's pretty interesting and it's pretty telling. Like that's a pretty good confirmation that is methylene chloride, especially given the fact that the one that boiled at 40 degrees was also had those same peaks. So I'm pretty confident that there's some methylene chloride in here. So that's interesting, I guess. Obviously, it didn't show up in the one that my dupe because I didn't put anything in there. But also, it's important to compare because there are some interactions that produce extra signals that you might not be expecting, and so we confirmed that those signals are not from just random combinations or interactions between chemicals. Something that you might be seeing is like, wow, those peaks are really big, but IR is not really a quantitative kind of experiment to run, so it doesn't really say like, wow, that's mostly methylene chloride. I have no idea what the proportions of methylene chloride of this is in here, and it would take a lot more testing for me to figure that out, so I didn't. Sorry. Interesting to know we've got methylene chloride in there, but let's see like what actually is the ingredients that take this nail polish apart. And so then I did a side by side test with straight out of the bottle, the magic remover, my dupe plus like a little bit, about 2% methylene chloride, and then straight up methylene chloride. And I just let those go. And as you can see, methylene chloride was the clear winner. Like, pure methylene chloride just ate that stuff up. You might notice it does this weird wiggly thing, and I think that is because methylene chloride is so small, it penetrates down through the layers of polymer and just kind of breaks things up. Like, could be the bottom, could be the middle, could be the top, I don't know, but it like gets all wiggly and weird, and I think that's the reason. Versus like acetone, it doesn't do that, but it takes off like one layer at a time, like just the top keeps like working at the top. That's why this nail polish remover is so different looking compared to acetone. The magic remover straight out of the bottle also works, and there is a difference here. Like, I'm not expecting the dupes to work exactly the same as the bottle because there is something to having that adhesive that really sticks it onto the nail. But you can see that anything with the methylene chloride works a little bit better than without. And based on all of this evidence, I think it's pretty safe to say that there's methylene chloride in the magic gel remover, and that's what makes it work. So, happy painting your nails. I had a lot of fun making this. If you have any questions at all, just like let me know. I'll try to answer them. I think I did decent science, but that's what it's here for, is always improvement. And that's what's really cool about science, is that you can just try stuff, try different techniques, see if you get the same results. Yeah, okay, I'm not gonna go on a science like monologue right now. This has been enough. This has been enough. Okay, bye. I'm not trying to expose any companies. Like, I'm just a grad student who's like trying to have fun. Don't sue me, I guess.